Java Virtual Machine is an essential runtime environment for executing compiled Java code. It stands for Java Virtual Machine, as which we have different JVM for different operating system, like different JVM for Windows, Linux or Solaris. But all the JVMs understand the bytecode given to it, no matter from which machine the bytecode is generated. This makes the Java platform independent, so it can be executed on any machine. The bytecode can be executed on any machine. JVM is a part of Java runtime environment. As we discussed, it's virtual, so it does not exist physically. We can't install JVM. It comes with JRE. JVM also provides several features including memory management, garbage collections, threading capabilities, securities. We can also customize the JVM by using the Java options. We can also allocate maximum and minimum memory for heap residing in JVM also. JRE is Java Runtime Environment, part of JDK, having Java class library, specific tools and a standalone JVM. It is the implementation of JVM that physically exists, and hence we can install JRE. It provides the platform to execute and run the Java program, consists variety of libraries in the form of .jar which are required to execute the program. We can run the Java program using JRE, but we can't compile the Java code using JRE, and it does not contain any compiler or debugger too. So the Java source code gets compiled and converted to the Java code, and then after that compiled code can be used by here. We can see JRE installed in variety of places like browsers, TV mobile, set-top boxes and other electronic gadgets too. If you wish to run this bytecode being generated or any platform, you always require this JRE on the different platforms or different places, as I discussed, different electronic gadgets. It acts as a layer on the top of the operating system because JRE is in these places use the JVM and executes the bytecode provided in the form of jar. Java runtime environment is also a powerful toolset designed to allow the end users to run the Java-based programs, offers the variety of security features like encryption and decryption and data transfer techniques. As I discussed, JRE is equals to JVM plus set of libraries plus other additional jar files, as I discussed. It consists JRE plus development tools also like compilers plus iterations and the debuggers. As I told you that it is the implementation of JVM. It physically exists and hence we can install this JRE. When we talk about this complete iteration, how the Java runtime environment executes this bytecode, the Java source code is basically compiled by the Java compiler and converted the source code or a .java file into the Java bytecode, which is also known as .class file. That .class file, which is the Java bytecode, is being given to the Java virtual machine, depending upon on which operating system you wanted to run your file or your code. Supported libraries will be enhanced based upon the program that you wanted to execute and run. That's what we call it as this bytecode is executable. Once you have this bytecode with respect of in whichever operating system you wanted to execute, you can run across. This is how JRE works. We do have JDK. JDK is basically stands for Java Development Kit, and it physically exists and we can install it. JDK consists JRE. JRE is a combination of JVM plus the class libraries. It contains all the compilers and debuggers and Java docs along with it. It contains JRE along with the compiler. We can write the Java code and compile the Java code with the help of these compilers and debuggers. Similar to JRE and JDK is also platform specific. We need to use separate JDK for different operating system. to convert it into the bytecode, all the libraries like Java, Javac, etc. exist inside the bin folder of the JDK installed path. I hope you know how to install JDK. That's what you need to set that bin path to your environment variables too. So this is how JDK plays an important role. This is how the combined picture of JDK, JRE and JVM comes into the picture. JDK is a superset of, you can see that this arrow is a superset of JRE, which contains the JRE along with the compilers, JRE along with the compilers. It does not contain other development tools like compilers, debuggers and etc. That's what we install JRE only to run the Java applications, not to develop them. JVM also cannot be installed and it does not have physical existence. That's what we have JDK set up where the bin folder path is required. It provides platform independence by converting the bytecode obtained from any machine into the corresponding machine instructions, but it is created only when we execute the Java program, not for the storage purpose. That's how the JDK helps in compiling, and then JRE can run that bytecode into the respective OS. I hope this picture is pretty clear to all of you. This is how the Java architecture works along with Java source code uses the Java compiler, converts into the Java bytecode. This bytecode is moved locally or through the network where you wanted to run your bytecode. Class loader bytecode verifier will verify the bytecode. The class loader bytecode verifier would be required to check on which particular operating system you wanted to run your Java file. Only then you can execute, depending that OS has to give a used support of JRE itself. Whatever third-party libraries would be required to run your bytecode would be taken from the JRE, added into this operating system. That's how the Java application runs. I hope you have a clear picture how this JRE, JDK and JVM plays an important role in writing or developing the Java application, compiling it into the bytecode and running it over the platform independent operating systems. Until next time, stay tuned. Thank you.